Continuing with the safety in the industrial system, we will now review hazard and risk reduction. A basic understanding of hazard and the possibility of hazardous events is essential for those involved in hazard studies. In other words, it's useful is to know what you are looking for. First of all, let's remember that definition of danger, an inherent physical or chemical characteristic that has the potential to cause harm to people, property, or the environment. We are not going to delve into hazard here, but it can be helpful to have a simple checklist and perhaps keep adding more hazard as ideas develop into your design. We must bear in mind that the subject of risk study is important, and at least we must know what it means to organize a risk study for a process or machine. Let's consider the dangers under a few main themes. General physical. We have moving object, collision, collapsing structure, and floods. And mechanical plant, we have pressure releasing effects, vibration, rotational machine, abrasion, machinery, uh, and machinery control failure, and welding torque. Considering the material, we have wrong identities, wrong size, failure due to stress, corrosion, cracking, chemical attack, fatigue. In electrical, we have flashover and burns, electrocution, fires, explosion of switchgear, power dips, wrong connection, loose connection. In chemical and petroleum, we have explosion, fire, toxic material release, mechanical failure, and wrong chemistry. In food processing, we have process error, failure to sterilize, and contamination of product. In biomedical, pharmaceutical, we have those toxic release of virus, side effects of drugs, infections are injurious, misuse of drug, packaging and labeling error, process error, wrong blend, and sterilization failures. In nuclear power, we have radiation, contamination, leakage of toxic material, loss of control, excess energy, steam, and pressure. In domestic, we have heater, cooker, strain case, swimming pool, and criminal. For our topic of security instrumented system, we need to take a closer look at the industry where active or functional security systems are commonly found. There are chemical manufacturing, petroleum refining and offshore, natural gas distribution, marine power generation, oil and furnace, mining and metallurgy process, manufacturing and assembly plants, railway train control, and signal system. Let's take the cause of chemical plant hazard and see how they relate to hazard study methods. This gives us an idea of how a combination of conditions should be tested to relate the condition that could cause an accident. Let's review some causes of explosion, fire, and toxic emission. Cause of explosion. To create an explosion, it's necessary to have together an explosive mixture or material and add ignition source. An explosion inside the container is said to be confined, while an explosion outdoor is unconfined. Explosion mixture occur when a gaseous full mixture with an oxidant, air, oxygen, The proportion of the mixture must be between the lower explosive limit is LEL and the upper explosive limit is UEL. In the table provides explosion and detonation limits for some common gases in air. Logic diagrams are used as a basis for representing combination of hazard and foul conditions, generally referred to as fail-free diagram. Therefore, an elementary logic diagram will look this in figure. Source ignition will include flames and hot surface spark due to electrical, mechanical, or chemical causes. Static electric, compression, impact, or friction. And ignition of any particular gas mixture require we have an energy level above a specific minute level and a temperature higher than the specific minimum. Therefore, it's possible to prevent electrical instrumentation from becoming an ignition. Its temperature and stored energy level can be limited by design. This is a form of break prevention. It should not be confused with a safety instrumented system, but is on the list of risk reduction measures. Let's talk about a hazard analysis methodology. Recognizing and understanding the security problem to be solved is the essential first step in avoiding this problem. This in turn requires that we understand the nature of the hazard and the contributing factor. Studies begin at the early possible stage of a project when the concept or process outline is established and are repeated in a greater detail as in design and contribution of the plans involved. Using this method, potential hazards are identified at the early possible stage in a design when corrective actions are easier to carry out. In box 1 we have concept, and the objective is preliminary understanding of the EUC and its environment. In requirement we have acquired familiarity with EUC and required control function, specify external events, determine likely source, information of nature, information of current applicable safety regulation, and hazard due to interaction with other equipment process. In the box 2 we have a scope definition. The objectives are define the boundary of the EUC and the UC control system, specify the scope of the hazard and risk analysis. In requirement, we have defined physical equipment, specify external events to be taken into account, specify subsystems associated with the hazard, and define the type of accident initiation events to be considered. In the box number 3, we have hazard and risk analysis. The objectives are determining the hazard and hazardous event of the EUC and the EUC control system, determine the event sequences leading to the hazardous event, and determine the EUC risk associated with the hazardous events. And requirement, we have a hazard and risk analysis, try to eliminate the hazard first, test all foreseeable circumstances, and sequence of events leading to the hazard event plus probability, and consequence to be determined.